To start off, we're going to make sure we have the Arduino IDE installed. Once we do, go ahead and launch it. We now need to configure the IDE to work with the NodeMCU instead of the Arduino Uno. So to do that, we need to add a board manager URL. That'll be in the description, so go ahead and paste it right here. Click OK. And then we are going to use Arduino's board manager. You can find that under Tools, Board Manager. And go ahead and type ESP A2 and it should pop up right here. You're going to want to click install. Wait for it to install. Should be pretty quick. Once that's done, we may need to restart, so one sec. There we go, okay. And to make sure it installed properly, you can go to Tools, Board, and then under here you should see all the ESP8266 modules, and you're going to want to, depending on what board you have, going to want to select NodeMCU 1.0, that's the one I use, and there you go, you should be set up. Once you have it set up, we can now start writing code to the NodeMCU. So to start out, we're going to make sure to connect your device to your computer with a USB cable. Make sure it's a data cable, not just a charging cable, otherwise you won't be able to push code to it, and it may not show up. Okay, and to test for that, we want to go to the device manager, which you can find by typing in device manager into the start, and scroll down to ports right here, this guy, and you're going to want to look for this thing on Windows, the CPU210X USB to UART. Just basically translates USB to a format the NodeMCU can interpret. And if you're on Ubuntu or Linux, you're actually going to need to install a driver for your computer to actually interpret or read it. Once you do that, keep note of the COM port it's on, and you're going to want to go to Tools, and on your COM port you want to make sure you type in 3 or select 3. Otherwise you're not going to be pushing to your MCU and Arduino is going to give you some errors. And we're just going to write some very simple code to blink the integrated LED on the device, just to make sure everything's working, so we can start writing some real code. So go ahead and upload. Pin 2 is the pin on the module that actually blinks the LED, and this just specifies it's an output, not an input. And then you're writing a low signal, and then you're waiting 100 milliseconds, and then you're writing a high signal, so it should blink pretty frequently. It does take quite a while to upload, up to a minute, so just be patient. And there you go, I'll insert some video of my MCU blinking, and there you go. You're ready to proceed to the next step. Now we're ready to connect to Wi-Fi. The very first step is you're going to want to make sure you are including the ESP8266 Wi-Fi file. If not, you're not going to have access to any of the functions we're going to use. So go ahead to the description, copy and paste this code right here. I'm going to go over it line by line, so don't worry if you don't understand it. Right here you have the serial.begin function. This sets the baud rate on the NodeMCU so it can talk to our desktop or laptop or whatever device you're going to use. This happens over the cable, so you're not going to see this when we detach it and work wirelessly. This is just mainly for debugging and whatnot. So make sure your serial monitor is at the same baud rate, otherwise your text is going to appear in symbols and it's going to be jumbled and you're not going to be able to read it. The next line right here, Wi-Fi.begin, you're going to use this format right here. I'm including my network ID and password in another file so you can't see it. So just between the quotation marks, put your network name and your network password. This block of code, actually all this right here, is just to show if your NodeMCU is connected or not. Right here, this loop right here, while your Wi-Fi is not connected, it's going to print a period every half second just to let you know it's still trying. Once it does happen to connect, it's going to it's going to print your local IP that's been assigned to the MCU to your serial monitor, and we're going to need to remember that number so we can work with it later. So open up your serial monitor and click compile. There we go. And it's going to take a minute or so to compile. And once we do this, we're going to start a WebSocket server on the NodeMCU so we can start talking to our MCU and start doing some cool things with it. So there we go. It's connecting right here. There are those dots that print every half second to let it know. Oh, there you go. And then it's connected, and you should get a very similar number, except these last couple digits This is just normally in numerical order from like the device connected to your Wi-Fi network. So this device right here is the 46th device connected. It could vary. You just need to remember this number. There you go. That's all there is to it. Before we start coding, we're going to want to install the Advanced REST client. This is basically an application that allows us to build complex requests to our device, but it also has WebSockets functionality, so that's why we're installing it. So you're going to want to install it, launch the app. I'll just show you the basics. So if you were going to use it with HTTP requests, which you can also use with the NodeMCU, you can build specific requests right here, add your headers, and then it will send all the details down here. So if we wanted to, we could just copy this link. Let's see. Make sure it's a GET request, and it will. This is all the code that goes into that page that it sent you. But for us, we're going to be using the WebSocket functionality, and what that's going to look like is it'll be, let's see, something like basically your IP port, and then you'll connect to it, and then it'll give you like a chat message window where you can start talking to your server. And I want to install the WebSockets library. So to do that, you're going to want to go to this GitHub link, which I have in the description. Go ahead, download the zip. It'll show up on your downloads once it's done. Then go to File, Sketch, Include Library, and make sure you're at the top. And go to Add Zip Library. And wherever you have it installed, let's see where it is. Yeah, right here. You're going to want to make sure you select the zip file, click Open. It'll install. I've already installed it, so it's going to give me an error. Once you've done that, go to, let's see, Sketch, Include Library, and then way down here, this WebSocket library should now be a thing that pops up here. You're going to want to click it. It'll automatically include all the H files you need, or all the H files involved. We're only going to need this last one, the WebSocket server, since we're not going to be using the NodeMCU as a client. It's just going to be a server, so you can delete those. And there you go, you have the WebSocket library installed. Start coding with the WebSocket library, so make sure you include the H file so you can use the functions that we need to use. Right here, we're going to create a WebSocket server on port 81. We're going to have to remember that. And then in the setup function, the only thing we're going to need to add is this code right here. We're going to initialize the WebSocket server, and then we're also going to attach a function to the onEvent event, basically. So anytime the WebSocket receives an event, it's going to use this function right here, which is this guy. It's going to use this every time that's called. So the only thing we're doing right here is we're printing the payload. Also, it is important that you use all these parameters. So we're going to print the payload. We are casting it to a char, so the serial monitor can output it because it's not designed to use the UINT8. And I'm just going to upload it real quick, so I can do this without waiting. And then in your, I'll disconnect right here. In your Advanced REST client, you're going to want to go to Socket, type in your IP address with this WebSocket right here, specify the port right here. Then we can open up the serial monitor. Oh, also, before I forget, the only thing you need in your loop function is this right here. Otherwise, it's not going to work, so don't forget that. And then serial monitor. Oh, okay, it's busy. Open up the serial monitor. It's connecting. In your Advanced REST client, wait until you get the connected. Make sure you have the same IP. Connect. Should take a second or two at the most. And then we can start communicating with our module wirelessly. I'm going to send hello. It gets hello. And just to prove this happens actually wirelessly and not over the cable, I'm going to do the same thing for my laptop. My laptop's also connected on the same network as the NodeMCU, and I'm using the exact same IP over here. And I am connecting. And there we go. And you should see message right here. Yeah, sent from laptop. So what we're going to do in our project is we're going to have, let's say, pattern equals 8 and see, where's the and symbol? There we go. Brightness equals 200. This is going to be sent either through an app or through a web browser wirelessly to the lights, and we're going to interpret the code and some patterns accordingly all over the air. And also, if you want to reference the guide I used, I will post it in the description. Okay, we're going to take a quick break from coding, and we're going to look up on how to wire your LED strip to your NodeMCU, and also installing the FastLED library. So if you have your node in front of you with the USB port downwards, you'll notice that there are tiny labels everywhere all around the board. If you can't see them, you can reference a reference sheet like this. Notice the ones we're going to use are the ground ones and the data pins over here, or the GPIO pins. So you can hook up. Actually, I'll show you a quick schematic of a FastLED strip. So most strips have two parts coming out of them. One of them is going to be only the black and red cable. That's going to be for powering your strip. And then your other one, it's going to look closer like this. Your white cable might be black, depending on like who you buy it from. That's the one that's most important, and that's the one we're going to be connecting to our NodeMCU. So we're going to connect the green, which is the data cable. We're going to connect that to any pin over here. Let's just do, or any pin that starts with a D. We're just going to use D6. That's the one I normally use. And then just make sure you remember the number. And then we're going to connect the white or black cable, depending on, like I said, who you got it from. You're going to connect that to any one of the ground pins around the board here. So once you've done that, you should be able to plug in your LED strip, and it should flash a color very briefly. If it doesn't, hopefully you don't have anything to worry about, but it should. And then it'll go blank again. So once you've done that, we're going to install the FastLED library. This is a library used for controlling the colors on the LED strip and the addresses and whatnot. It comes with some optimized functions, so you can do some cool things. So we're going to download it. I've already downloaded it several times. So once you've done that, you can do it like we installed the ESP8266 library, or you can just go straight into extracting it. I've already extracted it, so yeah, just extract it, and then once you've extracted it, you copy the folder. Actually, you know what? I'll just do it. I'll just do it real quickly. So extract it. And then in that folder, you want to rename the folder just to FastLED. The master is something that GitHub adds to it. And you're going to want to cut it or copy it, doesn't really matter. Just cut it because you're not going to use it in the downloads folder ever again. And then in your Arduino, you're going to want to figure out where your libraries folder is. And to do that, go to File, Save As, and then you'll notice right here, you have a libraries folder. And you're just going to want to paste it right here. I've already done it. And then once you do that, go to Tools, and let's see, Manage Libraries. And let it load, and you should be able to type in FastLED here and it'll say installed. So let's go see. Oop, maybe not. Oh yeah, we're good, Okay, FastLED, that's the one we're looking for. And once you do that, let's go to, I think you should just be able to, oh yeah, you should be able to include that. And then there you go. So if you type in, once you've included the library, if you type in fast and then LED cap, it should turn a different shade. That means you have successfully installed FastLED. So now we can actually start coding with FastLED. So let's go ahead and include the FastLED library right here. And because it's an installed library, make sure you use these brackets. I'm not 100% sure on why, but just use them or else it may not work. And then down here, the very first line of FastLED stuff, we're gonna create an array of LEDs, CRGB LEDs, and in your setup, I should have commented where I updated stuff. Oh yeah, the only line you need in setup is right here. this just calls the library and it adds libraries of the WS2812 spec on pin 6 and the color format green, red, blue. That's the order FastLED sends the information to the FastLED chips. That's just the order they interpret them. Your object and the amount again. Okay, so in your code, the only code you need to start getting stuff to work is right here. I will also post this in the description. So also one last thing, make sure you have the index1 variable. Don't name it index or else it won't work, because index is a reserved keyword. You can call it ind1 or ind or whatever you want. In your loop, you want to check if your index is taking up 300, because arrays start at 0. The very last LED will have the index of 299, so if it's greater than 299 you want to set it to 0, otherwise you'll get an index out of bounds error, which will crash your program or something like that will happen. So set it to 0, and in this case, so we're doing the pattern we're designing will be an LED that is a certain color that moves throughout the strip once every single loop, and it's going to reset the LED behind it back to black or like nothing. And the reason we need to set the LED behind it to a certain color is because FastLED is like a set and forget. So once you set it to a color and then unplug it, it'll stay that color. It doesn't default to blankness. So you'll need to, any LED you want to be dark that was previously lit up, you have to manually set it to turn off pretty much. Otherwise, we're just going to take the current index, subtract 1, and set that one to 0. And then down here, we're going to take the current index and assign it to, we're going to use hue, saturation, and value. And if you're not familiar with that, hue is the, ooh, that's a lot of windows, 1 second. Hue is the color, basically like the fundamental colors, like red, orange, yellow, green, aqua, anything in between. We're going to use aqua just because it's a nice color. And then the saturation is how vibrant, how strong or closer to the true color it is. If this was 0, it'd basically be white because there's no color added to it. It's not very saturated. And then the value, which is basically, I want to say the brightness. That's, in my experience, it's been the brightness. You could also do RGB if you wanted to manually set. You can change this to RGB if you wanted to. If you wanted to manually set the LEDs to that way if you wanted to. I'm not going to, just because I found this to be much easier to work with. And then every time you want the LED strip to update, you have to call FastLED.show, otherwise it'll process the information, but it's not going to send it over. And then you're going to increment the index down here. So just to quickly recap, I'm going to build while I'm recapping, just because it takes a while. So you have your LED object, you're adding it to, you're adding your strip, you're specifying the protocol, the pin, the color order, etc. And then in your loop, we are checking, making sure it's in the correct bounds, setting the one before it to nothing, and setting the one at the current index to a color, and then we're showing it, and then we're updating the index so it actually proceeds down the strip. So I will show a video of the LED strip in action. Let me just make sure it works. Perfect, okay. And that's your first successful pattern with FastLED. Congratulations. Now we are at the final stage for our video. We need to take what we learned in the first section with the ESP8266 over WebSockets and what we learned with FastLED and mash it together to make something kind of cool. So what we're going to do now is let's see what we want to do. So we get the code, or not the code, we get the text right here. So what we're going to want to do is we're going to need to do some processing on this text, so just, actually we'll keep that there. So we're going to make a string, set equal to that, and then actually let's just, for consistency's sake, we'll just do that. So now we have the text, which we can now manipulate. I'm just going to do something really simple because I don't want to do that much processing, and I don't think you guys want to either. It's not really in the scope of this tutorial. So we're going to do if txt equals, let's see. Okay, yeah, I know what I'll do. If txt, if the first character is equal to, let's see, a y, we will set the brightness to 255 or on pretty much. Then we also got to call FastLED.show, and if txt, and in case you don't know, this just grabs the very first character of the message you sent and checks if it's equal to y. So we're just going to check if the first character is equal to an n, and we will, let's see what we want to do. Copy this. This is just going to turn the strip on and off for now. So we will compile, and I'm going to control it from my laptop just to prove it's wireless. And we'll open up the serial monitor. Oop. Okay, wait until it uploads and then open the serial monitor. And I'll post my personal code for all the different patterns I have and the brightness in the description. I just don't want to do it right now because it's a lot of work and it's only on my laptop at the moment. Alright, there we go. So it's connecting. It's going to connect to the Wi-Fi. And then I got to open up the API, the RESTful API thing. Okay. Let's connect. I'm just going to do a test message really quickly. Perfect, okay. So I'm keeping an eye on my strip. I'm going to type in, what was it? I think N, I believe. Yeah, N. So theoretically, if I type this in and send it, the blue incrementing, or the turquoise incrementing LED should turn off. So I'm going to try that. And it did. So perfect. And let's see. I'm just trying to, oh, right. I got rid of that print statement. It's okay. Oh well. But the LED did turn off. I'll show you a video, and then I'll turn it back on. And turn it back on. Turn it back off. Perfect. Okay. And that's all there is to it. You're now done with the majority of this tutorial.